Just kidding, folks. Pardon the lack of volume last night on the vocals. The mic was turned off, so out of the thousands of videos and thousands of sound checks, it's pretty rare for that to happen. But guess what? I was celebrating over something classified, and so I won't be sharing why. So anyway, that was interesting. I muted myself for once. Anyway, that's the past 24 hours. If you've come for the freshest imagery you'll find in the known universe of the closest star, you've come to the right place. And welcome to the Daily Space Weather Show. And we've got some interesting CMEs to cover indeed. And we're going to come back to that in a minute. Let's take a look at what's going on in the southern part of the North American continent. Popocatépetl. Yeah, Popocatépetl there. There's Mexico City. And just to its northeast, you've got... Come on, everybody. Say it aloud. You can say it. Popocatépetl. It's got the accent mark right there on the accented syllable. Popocatépetl. So an interesting explosion there. A great ash cloud popping up to about 20,000 feet over the bucket list volcano for me. That's one that I loosely plan to visit someday, but not today. Anyway, let's see what else is going on. The Reykjanes Peninsula now becoming more likely to erupt once again. The ground uplift has returned to levels that were seen just before the December eruption. So expect Reykjanes to erupt again. So more alterations to the map there. Likelihood of an eruption. An eruption is imminent at the Reykjanes Peninsula once again. Also, Ibu exploding. Flight level 100 for Ibu. And you've also got the usual suspects here. Semeru, Merapi, Dakono. If you haven't said it aloud, come on, indulge yourself. Popocatépetl. And a bunch of write-ups there. Santiaguito and Guatemala also erupting, and Fuego and Nevado del Ruiz. And Revenador and Sabancaya. So quite a lot of volcanic eruptions happening here at the moment. Also, we'll cover earthquakes. And look, earthquake risk for the western plate boundary for the North American continent. We've been seeing lots of quakes up and down the North American western plate boundary. So the likelihood of a large quake there might be a thing. I mean, basically nobody's forecasting earthquakes except by seeing foreshocks. So anyway, there are the past 90 days, and as you can see here, we've got an earthquake drought. So facts. It's been a long time since we had a 7 or greater magnitude quake. Earthquake droughts end in large earthquakes. So that said, Fiji Islands had a 5.2. It was at extreme depth, over 350 kilometers. Papua New Guinea had a 5.5. There's a location of that north of Australia. That quake was at the surface at 12:11 this afternoon. Tonga had a 5.4. That was at extreme depth, nearly 280 kilometers estimated depth for that 5.4 magnitude earthquake at 14:07 universal time. And once again, folks, the west coast of the U.S., the western plate boundary for North America in general, has seen a lot of quakes. So, yeah, maybe earthquake risk. Next, getting back to some more space weather stuff. Let's cut to some massive filamentary eruption. So up here you might see a huge filament blasting off and then a Hyder flare following that as plasma splashes back down toward the chromosphere, the layer in between the photosphere where sunspots occur in the corona, which is what's mainly highlighted in this imagery. That is 193 angstroms, 60-minute running difference along with 304 angstroms. Ionized iron and helium, respectively. And we've got some spectacular imagery of that new sunspot there, that massive sunspot in the northeast, your screen upper left. So we'll get to that here in a moment. First, some space weather stats. So radio flux now back up to 170, and we are seeing an imminent large solar flare from that new sunspot. We'll get to that as well. It might happen during the video, so it's looking like it's ready to produce a large flare. Again, we've got some massive CMEs to cover as well. There's the radio flux over the past year. Black line is the radio flux. Red line is the sunspot number. Space Weather Enthusiast dashboard not forecasting any incoming space weather. Earth's magnetosphere for the past 4 hours. It's our geospace magnetosphere movie. We show 4 hours per day on the channel to show you what the magnetosphere is likely to look like based on a whole series of variables like the electron flux, the magnetic field strength and orientation, the solar wind density, solar wind velocity, etc. Next, our ground magnetic perturbations map. Again, lots of variables go into that. It's called the Space Weather Modeling Framework. If you want to read about it, go to the ground magnetic perturbations page, scroll down to the bottom, and you'll find a tab there that says details. Click that. There'll be a link for Space Weather Modeling Framework. You can download all the software. And yeah, that's the ground magnetic perturbations map. Here's our KP index, geomagnetically calm conditions, at KP 1.67. KP 1.67. So, no significant space weather, although we did have some minor CME impacts. We are seeing a little bit of an uptick here in the solar wind speed at the ACE spacecraft, located at Lagrangian point 1, about 1 million miles in between Earth and Sun. Next, the Discover, which is showing a little bit more reasonable data these days. And we are seeing separate solar wind regimes here, so a wavy filament making its way past the Discover. We've got this variation of about an order of magnitude there between 0.7 of a proton per cubic centimeter and about 7 protons per cubic centimeter. Ramping way down from what we were seeing yesterday, over 30 protons per cubic centimeter. So also the solar wind varying here between about 476 and about 330. So huge variations there in both the density and the velocity. Current conditions at Discover are showing as about 1 proton per cubic centimeter and only 340 kilometers per second. So a big downtick there in solar wind just in the past couple of hours. Our GOES magnetometers are next, and they're located way toward the outer portion of Earth's magnetosphere. They're at like 23,500 miles of altitude. The GOES 16 and GOES 18. Smooth there as no space weather's coming in. Next, we'll show the heliosphere. There is our magnetic scenario. Earth remains in a south pole current sheet. You can see some continued indecision in the location of the sector boundary crossing as the North Pole sector is approaching, shown there in green, but still looking like it's a few days out. Just keep in mind the magnetic environment can change with basically no warning. Next, our line of sight field plot. And that's a lot of info all at once. The photosphere magnetism in grayscale, the solar B field in blue, the polar fields in green and red for north and south. Yes, the north polar field is at the southern heliographic pole. That is because solar cycle 25 is an odd-numbered sunspot cycle. So at solar maximum for solar cycle 26, these will be reversed. I should say it's solar minimum. Well, anyway, I'm not going to get into it. It's the daily space weather. Here's our coronal hole line of sight field plot, and coronal holes are a super important feature, perhaps even more important than sunspots, but certainly related. It's just very mysterious how coronal holes are related to sunspots. So, that said, let's cut to coronal holes from SDO. There you go. There's the 211 angstroms wavelength, and you can see those coronal holes there around the equator becoming more well-defined as we forecasted about 2 or 3 days ago. There you go. Once again, a solar forecast coming true, something that this channel does. And yeah, it's something that this channel does, that's for sure. Actual forecasting? Yeah. Anyway, moving along to sunspots. And sunspot number has leveled out here just over 50. So if you are frightened of low numbers of sunspots at solar maximum, by all means, stay in your bunker. Don't go outside. Live in a Faraday cage. Do whatever crazy things you have to do because you're spooked of an inactive sun. For all of you folks who are spooked of an active sun, don't worry. We'll have an active, spooky sun soon, and the one set of cultists can leave the bunker and the other set of cultists can enter the bunker. Next, our flare probability monitor and scoreboard, which is down. The Integrated Space Weather Analysis Center is down, folks. So we ain't got nothing, but let's take a look at sunspots because, oh, we got something. Dude, you don't even know. We got some real close-up analysis here of a huge sunspot that is building in its likelihood of producing a large flare. So I don't care about the Space Weather Analysis Center or their flare probability monitor and scoreboard. The likelihood of an X-class flare has gone up a lot. So we'll show you why here. That is a 24-hour video at 30 frames per second featuring SDO 171 angstroms, 60-minute running difference, and the SDO magnetogram. Of course, sunspots are magnetic features taking place in the photosphere, which could be considered the, quote, surface, end quote, of the sun, or, better yet, the surface of the sun. So here we've subtracted the 171. We're going to show you why that sunspot is becoming increasingly likely to produce large flares. So let's zoom in, as in all the way in. And there is an absolutely spectacular view. Now, on the leading portion of this sunspot, this area right in here, you're going to see some, well, there's some opposite field there, but this area right back here, right in there, you can see magnetic shear getting closer and closer to this umbra. So that is an extremely unstable setup right there. In other words, this trailing umbra right here is moving faster than the leading umbra, which means it's going to overtake it, which means the magnetic shear is getting very, very high. That is a very high probability for an X-class solar flare. That is what we call a beta gamma delta class sunspot group, the most likely sunspot to produce a large flare. Beta means it has both magnetic fields. So this field here is a North Pole field. This field back here is a South Pole field. And when those magnetic fields get very close to each other, that is the increase in likelihood. So it's a beta class sunspot because it has both magnetic fields. It's a beta gamma class sunspot because a single vertical line cannot be drawn between the opposing fields. And it's a beta gamma delta class sunspot because it has some extreme magnetic shear with oppositely charged umbrae close to each other. Beta gamma delta class. There you go. It's defined for your viewing pleasure. So let's add, there's the 171 angstroms 60-minute running difference once again. You can see the way there's plasma orienting to those magnetic field lines. That is ionized iron is the chemical signature that is being noted by the 171 angstroms wavelength. It's part of the extreme ultraviolet spectrum. Here we've switched to the SDO continuum. So on the magnetogram, we use polarized light to determine the magnetic field orientation. In the continuum, it's basically like visible light, more or less. A series of different wavelengths there for the continuum. And sticking with the 171 angstroms 60-minute running difference. Now we'll subtract the 171. That's the ionized iron portion of the spectra. And there is just the series of sunspots. So as you'll see right back here, this area right here is the delta to watch. Because you're going to see that building and then moving toward that other umbra. You can see it a little bit in the continuum. And that is greatly increasing the likelihood of a large solar flare. So don't be surprised to see an X-class event out of that. We also see unstable plasma close by, which many believe is actually the mechanism that causes the flare. So on the channel, we don't typically say ever that solar flares cause coronal mass ejections. We say that they're associated with coronal mass ejections because in the realm of physics, if you say a thing is causal, it better be that the one thing causes the other thing. If you've got it backwards, if you say A causes B, but B actually causes A, then that's a problem. See what I'm saying? So here's just continuum by itself, and let's move on. Oh, check it out. We've also got there's the zoomed out. Not bad. And let's move on to solar flares and energetic particles. So that's next. Proton flux here back to baseline levels. The GOES X-ray flux here ramping up. So exactly as we stated, you can see this ramping up the background flux right now because of that sunspot 3590. I think it's 3590. Let's check. So if you ever want to look up the sunspot number, one of the ways you can do it is just go to the SDO data page and go to the magnetogram and click on the potential field surface source images. There you go, 3590. That is the sunspot to watch. And anyway, here come flares. Yeah, the background flux, check it out. The background flux right now is all the way up to a C2.3. So flare likelihood ramping up. It's all about sunspot 3590. And we're going to show you some amazing close-ups of it. There is the 131 angstroms, 60-minute running difference, along with 94 angstroms raw data. Raw dogging it with the 94 angstroms. Another species of ionized iron. There's a little close-up for you in those same delightful wavelengths. Still part of the extreme ultraviolet portion of the electromagnetic spectrum. Both 94 and 131 are ionized iron spectra. It's some very hot iron gas. In other words, it is iron star. In other words, where you see white, there's a lot of that species of iron, and when you see dark colors, there is a lack or a much lower amount of that species of ionized iron. There's the full disk view once again. Now we're showing the 94 angstroms 60-minute running difference along with the 131 angstroms raw dog. And we do have another sunspot there rising both in the southeast and in the south-southeast. So another feature that you're going to see, folks, Another feature that you're going to see, folks, is at solar maximum, we see sunspots at all active latitudes. So at around solar minimum, you'll only see sunspots around the equator. But around solar maximum, you see sunspots at all active latitudes. So that's just another standard feature of solar maximum. And let's move on to look at some more relaxed things. Here's a star chart. That's what's going on over our head. We're located in Lehigh Valley, Pennsylvania. Skyandtelescope.org is where you can make your own star chart. We've got a gibbous waxing moon up there in the constellation of Cancer. Next, how about a solar system forecast? It's theplanetstoday.com, by the way. And let's advance this 1 week as the Earth is all lonely on this side of the solar system, as Mercury will be the first to join us. That's where things will be in 1 week on the 28th. And is it a leap year? Oh my God, it's a leap year, which means it's my pal Chuck's birthday. We got to wish Chuck a happy birthday. Shout out to Chuck, one of the best climbers in the history of cycling. And I mean as in all climbers ever in cycling. It's crazy. That guy kicks so much ass and takes so many names that you wouldn't even know. But we're going to make a video, so then you'll know. The astronomy photo of the day is over the Pinnacles in California. The Pinnacles National Park, is it? I think it's the Pinnacles National Park. It's like the Seagull Nebula, which looks like the Thunderbird Nebula to me, but okay, or the Phoenix Nebula, but no, it's called the Seagull Nebula because reasons. But that's what it is, the Seagull Nebula. apod.nasa.gov if you want to check it out yourself. And let's move on to CMEs. Coronal mass ejections. People are spooked of those too. And most of those people aren't even astronauts, which makes little sense. But anyway, there are CMEs for today. That's 82 frames from George Mason University. And guess what? One of those is earthly directed, or has a significant earthly directed component. So I'm going to... No, not there. Right there. That one. That one. It's all right. Let's just show our custom coronagraphs because. So, this one right here, the one coming out of the northwest, that is an earthly directed CME, or it has an earthly directed component. And it looks like oh man, some missing data there. That is disappointing. Let's zoom back out for a minute. So unfortunately it's not showing it there, but we do expect that to have an earthly directed component because if you look where the filament came from, it was from quite in the earth-facing portion of the disk, and as plasma ejects from the solar corona, it has a tendency to expand. Now sometimes it does stay as very tight filamentary features, but typically it's going to expand. Keep in mind space is a near vacuum, so it's kind of a normal thing for gases to expand and become more and more diffuse as it gets farther and farther away from the solar gravitational field, magnetic fields, etc. So it's this CME right here that is likely to have an earthly directed component, and we can expect that to arrive sometime, let's see, late in the day. Hold on a minute. Someday like 3 days from now. So it's toward the end of the day today. So it should arrive late in the day on the 24th. Late day on the 24th, folks. CME impact expected. Not mostly earthly directed, so most of it will miss to the northwest, but there is going to be some ejecta likely to strike Earth. I wouldn't expect to see it get higher than a KP5 or maybe a KP6 at the maximum. So, but more likely only like a KP 3.5 to 4, I think. I don't think it's particularly earthly directed, but I believe there is a significant component that may cause a mild geomagnetic storm. Here's a closer view of that filament erupting. Same wavelengths there, except we've added the 193 angstroms 60-minute running difference. That's ionized helium at 304 angstroms and ionized iron at 193. So there's a great view of that filament eruption. It's there, and now it's gone. It's there, and whoops, there it goes. Or should I say, here it comes. Well, here comes part of it, at least. And let's move on to filaments. So there we go. There's Cerro Tololo's ground-based solar observatory. Again, sunspot 3590 becoming increasingly likely to produce an X-class solar flare. A great view of that filament eruption. Here it is. We should have named that one. You could have named that one after your friends, your foes, or even yourself. So maybe, I don't know, name this filament. It's right in the Earth-facing portion of the solar disk and just ahead of this sunspot that's likely to produce an X-class flare. Seems like a good sunspot to name. You know, I mean, what's better than naming a sunspot after somebody that causes a geomagnetic storm? Like, likelihood of coronal mass ejections that are earthly directed is extremely high right now. So it's, if you want to name filaments, do it over on Twitter, x.com/smashomash. So before we get to bonus features, here is the GOES 16 SUVI. You can see more CMEs popping off here as we make the video. That is the one that's coming our way. And of course, look at the likelihood of flares up there. You can see it is flaring, and look, facts are facts are facts. Anyway, let's zoom out to show the timestamps and get to bonus features. Charging hazards are first. We ain't got none. GOES electron flux, still kind of low. There it is. Electron shortage in the ionosphere. There's the 1-year graph, and electron shortage here since December. What to make of that? I don't know. Maybe I should ask a particle physicist. But we're having a segment tomorrow about asking a particle physicist, and that's not what the question's going to be. If you'd like to submit a question to the Ask a Particle Physicist segment, head to smashomash.com/forum, scroll down to the General Science Forum, and there's a thread for it. Or you can ask in the YouTube comments, but you're not as likely to get an answer that way. So anyway, there's the relativistic electron forecast, and NOAA is expecting a big dip. There it is. There's the forecast represented by the green box. Next, the layer where it's measured. How about the F layer, folks? What do you think? Are you too effed to understand the F layer? Well, there it is. Feel free to pause the video in this frame if you're not familiar with the data depicted. There's the ionosphere. And yes, I did indeed go to the Ben Shapiro School of Fast Talking. Anyway, that's the ionosphere, and it's looking quite nominally. Not very interesting. No geomagnetic storms, no major anomalies. If you were hoping to tune into the ionosphere to see doomsday forecasted, sorry, not in the forecast. Everything looks just fine. So yeah, doomsday, it's postponed again, just like every time some cultist or their high priest forecasts it. Next, the Global Ionosphere Nowcast, or WHAM. The whole atmosphere model on your device screen. When you look at that, you might not understand facts. If you don't understand physics, don't tell me the universe is electric. It's totally pseudoscience. What a crock of crap and total nonsense. I gotta stop singing Wham now. I apologize. For nothing! Anyway, here's the latest imagery. And, yeah, like I said, very high likelihood of X-class solar flares. Look at all... Oh, look at... It's happening as we make the video, folks. Yeah. So, let's, yeah, that's not bad timing. That's really good timing. So, there it is. There's the X-class flare that I literally just forecasted while making the video. There it is. See, once again, it's called forecasting and understanding how the data correlates to reality. There it is. X-class flare forecasted while I recorded the video. It would have been impossible for me to have faked that in any way. So, there you go. Cheers. And in fact, we've actually captured the moment of the flare here. So if we zoom in even further, you can actually see there's some crazy like field variation happening there. That's like literally the moment while the flare is going on. So, cheers. Yeah. So, anyway. Facts. I guess those are still controversial. There's even a song. They're like, what? Facts are... Oh, it's been a crazy 4 years, folks. Just a crazy 4 years. And congratulations on surviving. So far. Let's get to meteorology. So first we got this spooky face. I mean, look at this. This is so spooky. This is the pressure. So look, we got this low right here. And then there's this low right here. It looks really mad. Look at that. Oh, look. Oh, no. It's the smirking smile face of death. Low pressure systems over the northern hemisphere. Oh my God, it means civilization is ending, folks. Civilization is ending. Everybody hide in your bunkers. Don't go out in the sunlight. It's very dangerous. Take vitamin D supplements that we sell you at amazon.com/shop/smashomash instead. Pardon my sarcasm. Anyway, those are surface winds and mean sea level pressure as opposed to nice sea level pressure. And check it out. The northern hemisphere has got the lowest pressure and the highest pressure. Look at this high pressure zone. That is one hell of an anticyclone. Look at that, folks. Dag! That is a crazy anticyclone. Look at that thing. All right, I stand corrected. It's just a high pressure zone of massively cold air. Let's check the temperature. That's looking on the chilly side. Negative 41, negative 52 Fahrenheit. That's pretty on the cool side. That's not the kind of weather to go on a barefoot walk. Anyway, that's the coldest place in the world, and let's move on to our regularly scheduled meteorology segment. Surface winds. Surface winds, those are a thing. And there they are. Shout out to my viewers from the east side. There are your jet streams. Shout out to my viewers from the central world. There are your jet streams, and here are your surface winds while I'm at it. And there are the surface winds of the west. Shout out to my viewers from the west. There are your jet streams. Claim ownership of the jet streams. Say, those are yours. The universe is yours, folks. Or something. Here are clouds and fog over the Americas. And I'm pretty sick of standing. I got to get this video completed so I can get it uploaded onto your screen. Turns out some of our viewers thought we were live streaming these videos. These videos are uploaded. Anyway, there is the sea temperature. We're showing sea temperature. And look at this, folks. Look at this. Once again, oh my God, it turns out that civilization is destroyed. Except, whoops, the Gulf Stream is still warming up places like Iceland and Ireland and Norway. So, yeah. Pardon my sarcasm once again. I have a tendency to mock utter hack frauds on YouTube who talk utter nonsense on YouTube and then successfully gaslight their viewers and complain about censorship while censoring their own viewers' comments. Think about how pathetic that is. If you're whining about being shadow banned and you mute your viewers' comments, you should seek psychiatric help because you are knuckin' futs. Anyway, they are the world's sea surface temperatures. And once again, sorry, not forecasting doomsday based on that either. Let's move on to our weather.gov map. And oh my God, look at this doomsday. Still not in the forecast. It's ruining my whole model for doomsday. Shout out to all of our catastrophist viewers. Did you know that the end is near is the oldest grift of all time? Yeah, you've fallen for the oldest grift of all time. The end is near, do what I say, and move to my cult compound. Otherwise, you might not survive the spooky, spooky, ridiculous things that I've forecasted. 'Cause I'm a prophet or something. Anyway, forecasts. There are forecasts, just like the X-Flare forecast. And there you go. That's a 72-hour GFS forecast for pressure and precipitation. Same model. Total accumulated snow depth in inches. 3 days. GFS. Accurate. Total accumulated precipitation. Accumulated snow depth change in inches. Total accumulated precipitation in inches. 72-hour GFS. And 72-hour GFS temperature anomaly forecast in degrees Celsius. Some warm weather coming to the east, and we'll take it. We'll close out with lightning. Real-time lightning, courtesy of blitzortung.org. Come on, then. Please connect. I'll press refresh. There you go. There are the active lightning cells on the portion of the planet that has lightning sensors from blitzortung.org. And here is U.S. Doppler radar. Blow! Vertical motion in the air column. The lower 48 is where we shall fixate for the remainder. By the way, these videos feature white noise, courtesy of mynoise.net. Mynoise.net. Yes, it's actually pink noise, I guess. Technically speaking, it's pink noise. And so if you listen, you hear that. That is our pink noise sound. We put that there on purpose, so it sounds like you're in the -D Enterprise. You know, Captain Picard's Galaxy class NCC 1701-D Enterprise. When it's at warp, it makes that sound. You know, that's what it's designed to be like. Because space. So check it out. Perhaps if you like, mynoise.net. Create your own pink noise. Anyway, we'll close out with clouds and fog and water vapor. Here's your recap. Doppler radar. clouds and fog. And the water vapor, highly recommend you check out the water vapor map when you're not sure what's going to happen with your Doppler. If you realize things like, dry air is more massive than moist air, and lows suck and highs blow. If you understand that, you'll be able to forecast your own weather. Impress your friends and foes by being able to forecast your own weather. It's pretty easy, and the smaller the area, the easier it is. Anyway, thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back. While I go back to the bunker again, I like to hide it down here and not invite my friends.